Hello everyone, so today we're going to be looking at the four kinematic equations. And right here on the screen, you'll see the four kinematic equations that we'll be using to calculate either velocity, acceleration, time, or distance, depending on what the problem is asking us to do. So the equation side, we have velocity equals initial velocity, the VO or V naught will stand for initial velocity plus acceleration times time. Then we have distance, which is symbolized by the letter x, equals to initial velocity plus velocity divided by 2 multiplied by time. Then we have distance equals initial velocity times time plus acceleration times time to the second power divided by 2. And finally, we have velocity to the second power equals initial velocity to the second power plus 2 times acceleration times distance. Now we have this first problem here. Let's go ahead and target it and let's try to solve it. It says, starting from rest, the runner accelerates at 3 meters per second square for 10 seconds. What is the final velocity of the runner? Okay, so after I read the problem, I have created a table on where I have all the variables that are given within all the four kinematic equations. Okay, we can see initial velocity, the velocity, which can be also the final velocity, time, acceleration, and distance. Okay, so starting from rest, right there, the problem is specifying that the runner is not moving at the beginning. So if a problem says that, we can immediately think that the initial velocity will be 0. No, give me a second. Right there. So the initial velocity will be 0 meters per second. And it accelerates at 3 meters per second square. So we know that we also have acceleration. And it's right here. We know it's acceleration because of the units, meters per second square. We see those units, we can immediately think acceleration. So meters per second square, right there next to it. I'm writing down whatever I have given in the problem, then I can target whatever they're asking me to solve in the problem. For 10 seconds, seconds is a measure of time. So t is the variable for time. We have 10. So 10 seconds. Great. Now the problem is asking us to find the final velocity of the runner. Now, we don't have distance. Distance is not given. So we can cross that out. And they're asking us to find the final velocity, with which velocity the runner will end up when it accelerates at 3 meters per second square. Now, if we go back to our four kinematic equations, we just got to pick the one that has initial velocity, time, and acceleration, and also final velocity. If we look at number 1, we have exactly what we need: initial velocity, acceleration, and time. So going back to the question, we can write down the formula: velocity equals initial velocity plus acceleration times time. There you go. Once we have written down the formula, we can start replacing the values for the ones that the problems are giving us. So initial velocity is 0 meters per second plus acceleration, which is 3 meters per second squared, times the time, which is 10 seconds. Now, 0 is not going to do anything. If you add 0 plus any other number, it will give you that same number. So in this formula, we can cross this out. We don't really need it. What we have is 3 and 10, and that is in multiplication. Okay, just a reminder, just because you see the second power up here doesn't mean that you have to raise the 3 to the second power. The second power is just part of the unit, and that's how we know that is acceleration again. Meters per second square. So, which is multiply. 3 times 10. That is 30. So, hold on. We're still missing one thing. the units. What are units for velocity? Well, just as the units for the initial velocity, which is meters per second, the final velocity units will be the same. 30 meters per second, and that